In this video, you will learn about general processes that scientists use for discovering and testing ideas. So we have here the 6 steps of scientific method. Number 1 is asking question about something you observe. Number 2, doing background research to learn what is already known about the topic. Number 3, constructing a hypothesis. Number 4, experimenting to test the hypothesis. Number 5, analyzing the data from the experiment and drawing conclusions. And lastly, communicating the results to others. Based on my research, you should have to follow the 6 steps of scientific method to have discovering and testing ideas when having an experiment. And now let's move to the how scientists learn nature. So we can see here the goal of science. So scientists seek to understand the natural world. Scientists begin with a question and then try to answer the question with evidence and logic. A scientific question must be testable and it does not rely on faith or opinion. And now let's move to the scientific method. The scientific method is a series of steps that help to investigate a question. Scientists use data and evidence gathered from observations, experience, or experiments to answer their questions. So, as stated in the previous slide, in scientific method is a series of steps that help to investigate a question. So, the most important thing a scientist can do is to ask questions. And now let's move to the research. So, the best thing the scientists to do is to have a research. So, to know the answer of a question, the scientist first finds out what is already known about the topic by reading books and magazines, searching the internet, and talking to experts. And the pictures intended or included in this slide is taken by me. So, for instance, you can utilize all of the magazines or any books you can be able to see in your house. And now let's move to high hypothesis. With the information collected from background research, the scientist creates a plausible explanation for the question. When we say possible, it should be seemingly reasonable and probable, so it should be skilled for a simple persuasive arguments, especially ones intended to deceive. To support or refute a hypothesis, the scientist must collect data. A great deal of logic and effort goes into designing tasks to collect data so the data can answer scientific questions. Data is usually collected by experiment or observation. Sometimes improvements in technology will allow new tasks to better address a hypothesis. So this is a part of having a simple device to collect a data, so what we call the data collection. And now we gotta move to conclusions. Scientists study graphs, tables, diagrams, images, descriptions, and all other available data to draw a conclusion from their experiments. An answer to the question based on the results of the experiment was the hypothesis supported. So this is the data science Venn diagram. So the first is automation, followed validity and intuition. So they have in under automation and validity, they have the same draft, insight, and bias. While on the automation, we have the same with intuition for and prevent. So as a general, they are the same with insight. With the validity and intuition, they have both biased. And now let's move to the theory. As scientists conduct experiments and make observations to test a hypothesis, over time they collect a lot of data. If a hypothesis explains all the data and none of the data contradicts the hypothesis becomes a theory. So the picture shows that to make any theory, we should make an observation first, and then ask a question, and then form a hypothesis that answers the question, and then make a prediction based on the hypothesis. And then that's the time to do an experiment and to test the prediction. So this is where we can see or analyze the results. So if your hypothesis is correct or your hypothesis is incorrect. But if your hypothesis is incorrect, we should try again to form a hypothesis that answers the question. So we're gonna ask questions from but based on the data collection or that that is intended in your experiment. So until make it again to make a prediction based on the hypothesis and then do an experiment again to test the prediction until you can get the hypothesis correctly, and then you can see the proper or the result. And now let's move to the scientific models. So we have here three types of model. Our first is a physical models. Second is a conceptual model. Third is a mathematical model. Physical models are physical representations of the subject being studied. Second, a conceptual model. Conceptual model ties together many ideas, is an attempt to explain a phenomenon. Lastly, mathematical model is an equation or set of equations that takes many factors or variables into account. So how important the community in science? So this is the importance of community in science. Scientific discovery is best when it is the work of community of scientists. For a hypothesis to be fully accepted, the work of many scientists must support it. The scientific process has built-in checks and balances. In general, the scientific community does a good job of monitoring itself. While new ideas are often criticized, if continued investigation supports them, they will eventually become accepted. So safety in science is also part of the community in science. So we have here accidents happen from time to time in everyday life, and science is no exception. So we all know that because we could never predict what will happen to our tomorrows. So, indeed, scientists often work with dangerous materials, and so scientists and even science students must be careful to prevent accidents. So, we don't know. So, if we are in a laboratory making experiments, we should be careful and follow all the guidelines. If you work in the science lab, you may come across dangerous materials or situations. Sharp objects, chemicals, heat, and electricity are all used at times in earth science laboratories. By following safety guidelines, almost all accidents can be prevented or the damage can be minimized. For examples of safety equipment in the laboratory. So, this should happen inside the science laboratory only. But but it doesn't mean that you only have to apply it inside the laboratory when you are doing experiment, but also if you are doing any experiment outside of the laboratory, you should also be careful with that because this can be dangerous to your health or to yourself. On this page, here are some guidelines to be followed inside the first, we should follow directions at all times. Obey safety guidelines given in lab's instructions or by lab supervisor. A lab is not a player area. Use only the quantities of materials directed. Check with the person in charge before you deviate from the lab procedure. Tie back long hair, wear clothes, 2 shoes, and shirts with no hanging sleeves, hoods, or drawstrings. Use gloves, goggles, or safety aprons when instructed to do so. Use extreme care with sharp or pointed objects like scalpels, knives, or broken glass. Never eat or drink anything in the science lab. Dangerous substances could be on the tabletops. Keep your work area neat and clean. A messy work area could lead to spills and breakages. Clean and maintain materials like test tubes and beakers. Leftover substances could interact with other substances in future experiments. Be careful when you reach. Flames, heat plates, or chemicals could be below. Use electrical appliances and burners as instructed. Know how to use an eye wash station, fire blanket, fire extinguisher, or first aid kit. Lastly, alert the lab supervisor if something unusual occurs. An accident report may be required if someone is hurt. The lab supervisor must know if any materials are damaged or discarded. Let's move to lesson summary. The goal of science is to ask and answer testable questions. Scientists use a sequence of logical steps called the scientific method, which involves making observations, forming a hypothesis, testing that hypothesis, and forming a conclusion. Physical, conceptual, and mathematical models help scientists to discuss and understand scientific information and concepts. A scientific theory is a hypothesis that has been repeatedly tested and has not been proven false. Safety in the laboratory as well as in the field are essential components of good scientific investigations. And now let's move to my next topic. It's all about matter and what happens when it undergoes change. And now, this is a new substance is formed. So in a chemical change, your chemical and physical properties of the substance are formed. In a chemical change, the chemical and physical properties of the substance formed will be different from the original substance, just like what the pictures showed below. So the first picture is not melted yet, and then the second picture it is melted yet. So that's what we called chemical change or a new substance is formed. There are two types of change in matter. First is physical change and then a chemical change. As the name suggests, a physical change affects a substance's physical properties and a chemical change affects its chemical properties. So I have some examples here. So is a physical change just like a pencil whenever you cut it, it's still the same but the shape is not the same. In chemical change, if you have a wood and then if you fire it, it will turn into ash. So that's what we call chemical change. And now let's move to when matter loses or absorbs energy. Changing states of matter occur when matter loses or absorbs energy. When a substance absorbs energy, the atoms and molecules move more rapidly and thus increase kinetic energy pushes particles for enough that they change form. We can see here the solid, when it turns into gas, that's what we call sublimation. When a gas turns into liquid, that's what we call condensation. And then when a liquid turns into solid, that's what we call freezing or solidification. But okay, let's reverse it. When the liquid turns into gas, that's what we call evaporation. When the gas turns into solid, that's what we call deposition. And when the solid turns into liquid, that's what we call melting. Matter will change in shape, size, state, and appearance. We can cut the paper into different shapes, but it's still paper. In chemical change, the matter will be converted from one state to another state. So example, the wood changes into smoke and ash, then it will produce heat and light. The state of matter can change when the temperature changes. Generally, as the temperature rises, matter moves to a more active state. The word phase describes a physical state of matter. When a substance moves from phase to phase, it's still the same substance. So just like boiling a water that I have boiled this morning, when I boiled the water, is still the water that I've seen before I put it in caldera. It's still the same. The water is still the same, but the temperature has rises. That's it. Matter moves to more active state. Everything is made up of matter, even if it is living or non-living things. Matter is important because it makes up everything around us, and matter cannot be created or destroyed, but instead, they just transform into a different form. So that's all. Thank you so much for watching my video presentation about how scientists learn or testing ideas, and then lastly, the chemical and the physical change. By the way, all pictures were taken by me, so that's all for this video. So thank you so much for watching.